Welcome to the Deep Dive. We're the podcast where we sift through stacks of sources, really digging deep to bring you the most compelling insights on complex topics.
That's the goal.
Today, we're plunging into one of history's most, enduring mysteries, the Shroud of Turin. But here's the twist, right? We're not broadly debating its authenticity today. We're focusing just on the image itself.
Important distinction.
Yeah. Our mission for this deep dive is hyper-focused. It's all about the linen cloth itself, the very fabric that holds, potentially so many secrets. Okay, let's unpack this. We brought together a really rich collection of sources for you. Cutting-edge scientific studies, meticulous textile analyses, some fascinating archaeological findings, and of course, crucial historical accounts.
A real mix.
Exactly. Our goal is to extract the most important nuggets of knowledge from all this material, giving you a kind of comprehensive shortcut to understanding what this remarkable fabric can truly tell us. We'll explore its construction, its intricate details, the various marks of damage it's picked up over the centuries, and even the subtle environmental clues it carries, all to uncover the silent story woven right into its threads.
It's true. You know, while so much of the popular discussion around the shroud tends to gravitate towards the image, or maybe the broader theological debates.
Right, big question.
Exactly. The physical properties of the cloth itself are often, overlooked. Yet, as we'll dig into today, the very fibers and the weave of this ancient linen contain an astonishing wealth of, frankly, forensic data.
Forensic data.
Yeah. And this data offers profound insights into its age, its geographical origin, and its long, incredibly complex journey through history. It's really a powerful testament to just how much information can be preserved within an artifact if you know precisely where and how to look for it. The fabric's blueprint, anatomy of an ancient linen.
Okay, so let's start right at the beginning. The very framework of the shroud, its dimensions. When we think of an ancient artifact, we often assume its size is fixed, right? A static measurement.
You'd think so.
But with the Shroud of Turin, its reported dimensions actually present a really intriguing puzzle. They kind of hint at a dynamic past. So after these extensive conservation efforts back in 2002, which, stabilized the cloth for flat storage, its dimensions are now pretty consistently measured. It's approximately 14 feet 6 inches long by 3 feet 9 inches wide.
Which is about 4.42 by 1.14 meters for those using metric.
Right. But here's where it gets interesting. Before those 2002 efforts, the dimensions people most often cited were actually slightly different. More like 14 feet 3 inches long by 3 feet 7 inches wide. So 4.34 by 1.09 meters.
A small difference, but significant.
Exactly. It's not just a measurement error. It's a crucial clue. These aren't, the shroud's original weaving specifications. They're approximate measurements for an ancient cloth that's been handled, stretched, displayed, folded in all sorts of ways over centuries.
Think about an old tablecloth.
Yeah, exactly. Like an old family linen tablecloth.
Yeah.
After years of use, washing, maybe being pulled tight on a table, it's rarely perfectly square anymore, is it?
Not at all. And this is where, the historical anchor truly begins to set. Studying these subtle dimensional changes immediately helps us connect the shroud to a much broader historical context. It hints at its geographical origin and an ancient measurement system.
An ancient system.
Right. The compelling hypothesis, and it's supported by some really meticulous research, is that the more accurate original dimensions used by its crafters were likely based on cubits.
Cubits, okay, like in ancient Egypt.
Well, specifically, it's proposed that the shroud was originally woven to be precisely 8 cubits long by 2 cubits wide.
8 by 2 cubits.
Yeah. And this cubit measurement becomes incredibly significant when we consider the historical context. We're likely talking about the ancient Assyrian cubit. This was a unit of length that was roughly 21.7 inches, or about 55.1 centimeters. And this particular unit wasn't just some abstract ancient standard. It was demonstrably in common use in the area of Palestine during the 1st century.
Palestine, 1st century.
Okay, I'll say where this is going.
Exactly. So if we connect this to the bigger picture, studying these dimension changes immediately sets up a historical anchor, hinting at its geographical origin and an ancient measurement system. If the shroud's original dimensions really do correspond to these specific cubit measurements, it provides a powerful indication, a suggestion that it originated from that precise region and time period. It aligns perfectly with ancient Near Eastern craft practices, not the later standards of, say, medieval Europe.
That's fascinating, just from the size changing slightly over time.
It's a subtle, but I think profoundly impactful piece of the puzzle, right from the very start.
Okay, now if you thought those overall dimensions were interesting, prepare to zoom in, way, way in, like beyond what the naked eye can possibly see. Here's where it gets really interesting when we zoom in, way in.
To the micro level. Exactly. This is where the shroud truly reveals itself as, well, a marvel of ancient textile technology, even at the microscopic level. Get this. The nominal thickness of the entire linen cloth, surface to underside, is remarkably fine, just 0.014 inches.
Which is what, about 0.35 millimeters?
Yeah, a mere 0.35 millimeters. That's incredibly delicate for a piece of fabric that supposedly endured millennia.
It really is.
But the detail goes even deeper. The individual threads woven together to make this cloth, they aren't much larger. Their mean diameter is only 0.010 inches, so 0.25 millimeters.
Still tiny.
And each of those threads isn't a single strand. It's a bundle, meticulously composed of anywhere from 70 to 120 even finer linen fibers.
70 to 120.
Yeah, and these individual linen fibers themselves are astronomically tiny. Their diameter ranges between just 0.000004 inches and 0.00008 inches. That's 0.010 to 0.020 millimeters.
Wow.
To put that into perspective, the diameter of a typical human hair is significantly thicker than these individual linen fibers.
So we're talking incredibly fine work.
Just imagine the skill, the patience involved in spinning and weaving material of this incredible fineness without any modern machinery. It's mind-boggling.
It absolutely is. And this raises an important question. How do scientists even go about measuring such minute details with such precision on an ancient, delicate artifact? The methodology here is really key.
Right. You can't just take a ruler to it.
Exactly. We know, for instance, that during that landmark 1978 STIR-P-ART expedition, the Shroud of Turin research project physicist John Jackson undertook a systematic process of measuring the cloth thickness. He used a meticulously zero-checked micrometer, ensuring absolute accuracy.
Zero checked, okay.
Yeah, so calibrated perfectly.
Right.
And his colleague, Ray Rogers, diligently recorded every single data point as Jackson precisely worked his way across various sections of the shroud. Very careful work.
So what did they find? Was it uniform?
Well, what these measurements consistently showed was a remarkable uniformity, actually. For example, on the frontal part of the shroud, Jackson found thicknesses consistently hovering around, say, 350 microns, 342, 355 in some spots.
Okay.
On the dorsal part, the back image, readings were similar. 391, 358, 348, 363 microns, generally around 360, 390. And even in areas like the dorsal foot area, which you might think experienced different wear.
Right. Maybe thinner there.
Actually, still very consistent. Around 318, 313, 331 microns, so roughly 304 and 330. It's noteworthy that Jackson made no measurements below 300 microns at all.
So consistent minimum thickness.
Exactly. What these numbers really tell us, besides the incredible precision of the measurements, is the impressive consistency of this ancient handmade fabric. It speaks volumes about its quality and distinctiveness for its time.
And the number of fibers per thread. You said 70, 120.
Right, and the fact that it isn't perfectly uniform, that it varies between 70 and 120, is actually, for textile experts, a telltale sign of handmade ancient textiles. It contrasts sharply with the machine-spun uniformity you'd see in later periods.
Ah, so the variation is actually evidence for it being handmade and ancient.
Precisely. These minute details, obtained with scientific precision, are absolutely crucial for understanding the artifact's authenticity and the technological capabilities of its time. They provide a tangible link to ancient manufacturing processes.
So we've talked about the incredibly fine threads, but what about how they're actually put together? The weave itself, the actual pattern in which these threads are interlaced, is apparently incredibly distinctive and tells its own powerful story.
It really does.
So what does this all mean for the weave itself? The sources state clearly that the cloth is woven in what's known as a 3-to-1 herringbone twill.
3-to-1 herringbone twill, that sounds complex.
It does. So for anyone who isn't a textile expert, let's try and break that down visually. It's actually a beautiful and complex pattern. Imagine a traditional loom, okay?
Okay.
You have warp threads. These are strung tightly onto the loom, usually running vertically. They form the foundational long length of the cloth. That's the shroud's impressive 14-foot-plus dimension.
Got it. The long threads.
Right. Then you have the weft threads. These are passed horizontally across the loom, weaving over and under those warp threads to create the fabric.
Okay, the cross threads.
Exactly. Now, for the shroud-specific weave, the weft thread does something particular. It passes over 3 warp threads, then dips under just 1, then over 3 again. Over 3, under 1, over 3. Repeating across the full width.
Over 3, under 1, okay.
This creates a repeating pattern that gives the fabric its strength and texture. But the twill part means there's a clever offset. Each succeeding weft thread is shifted 1 warp thread either to the right or to the left.
Ah, so it creates diagonal lines.
Precisely. Like you see in denim fabric, those characteristic diagonal lines. And finally, the herringbone aspect means that this diagonal offset, the twilling, periodically reverses direction.
Reverses.
Yeah. Instead of the diagonal lines always running in one direction, they switch back and forth. This creates a striking V-shaped pattern that, well, apparently looks like the interlocking bones of a herring fish. Hence, herringbone.
Okay, I can visualize that now. The V shape.
It's an intricate rhythmic process. And when you try to imagine ancient hands meticulously creating this fabric without any automated tools, you really start to grasp the extraordinary skill and artistry involved.
That's a crucial point because this specific weave, this 3-to-1 herringbone twill, and its particular stitching are described by textile experts as, quote, very distinctive and quite rare for any period.
Rare even compared to other ancient textiles.
Well, certainly complex. And what's truly compelling about this is that it's not just a casual observation. It's a conclusion backed by significant textile research, and it carries profound implications for the shroud's age. Take, for example, the work of the late John Tyrer, a textile researcher from Manchester. He did detailed X-radiograph studies of the shroud, and he came to a rather surprising conclusion. He stated that the shroud is a very poor product when compared to the finely crafted, often flawless medieval European fabrics we see in museums.
A poor product? That sounds counterintuitive.
It does initially, but he clarified. He observed it was full of warp and weft weaving defects. Little inconsistencies. He was left with the distinct impression that the shroud cloth itself was a much cruder and probably earlier fabric than the backing and patches added later, like after the 1532 fire.
Ah, so cruder compared to later medieval standards.
Exactly. His powerful takeaway was that this finding, more than almost anything else he'd seen about the textile, quote, lifts the shroud out of the Middle Ages.
But how can it be poor and also special in antiquity, as another expert said?
Right, that's Mechthild Fleury-Lemberg. And context is everything. Tyrer's assessment of poor is against the highly refined, almost machine-like standards achieved by later medieval European weavers. But special in antiquity refers to the rarity and complexity of the herringbone weave itself for its era. In the ancient world, this pattern was less common than simple plain weaves. It required greater skill, more time, and thus it was highly valued.
So complex for its time, even if not perfect by later standards.
Precisely. And this perspective is reinforced by the experience of Michael Tite, who led the British Museum's 1988 radiocarbon dating project. He conducted an extensive search for a comparable medieval control sample to use alongside the shroud in the dating. Despite exhaustive efforts, he, quote, could find nothing that reasonably matched the shroud's unique herringbone twill weave from the Middle Ages.
No medieval match found. Interesting.
But while medieval parallels were notably absent, archaeology has provided compelling ancient connections. Researchers have found ancient wool artifacts, not linen, but wool, featuring a similar herringbone weave in the ruins of a Roman fort in Egypt, dated convincingly to the 1st century.
1st century again.
Yes. And Mechthild Fleury-Lemberg, the textile expert who oversaw the 2002 preservation, a leading authority, she explicitly stated that despite its weaving defects, the herringbone pattern itself would have been considered very special in antiquity in Palestine.
I'll sign again.
Yes. So what's fascinating here is that this combination of primitive technique, by later standards, yet special pattern for its time, is a powerful indicator against a medieval origin. It aligns instead with ancient practices and a specific geographical context. 2. The linen's historical canvas. Marks of time and event.
Okay, so beyond the weave itself, the very fabric holds even more subtle secrets, like faint whispers from the past. When you look at backlit photographs of the shroud's linen,
Shining light through it.
yeah, exactly, you can actually discern darker and lighter banding running through the cloth. It appears in both directions, vertical, the warp, and horizontal, the weft, though apparently it often seems more intense across the shorter weft dimension.
Subtle stripes, almost.
Kind of. Now, this banding is incredibly difficult to spot with the naked eye under normal light. You might catch a glimpse in some photos, maybe a bit more visible in negative images, but where it really leaps out is when these images get computer enhanced, especially those backlit photos.
So technology helps reveal it.
Definitely. It's a very subtle visual artifact, But its presence is incredibly significant because it seems to speak volumes about the ancient manufacturing processes used to make this linen.
This is a remarkable example, really. If we connect this to the bigger picture, a seemingly minor visual artifact like banding becomes a powerful timestamp. It links the shroud's production method directly to antiquity and documented historical practices.
How so? What causes the banding?
Well, the cause can be traced directly back to the specific way ancient linen was traditionally produced. It seems to happen when individual collections or batches of flax the plant linen comes from have slightly different natural colors.
Different batches of the plant.
Exactly. And this slight variation in color arises because each batch of flax was retted and then bleached separately.
Retted. What's retting?
Good question. Retting is the crucial ancient process of soaking flax stalks in water. This helps to separate the useful linen fibers from the main stalk of the plant. It's a decomposition process, essentially. So after retting, these separate batches, maybe slightly different shades to begin with, were then spun into hanks of thread and mildly bleached. When these slightly varied color batches were woven together into a larger piece of cloth,
You get the banding.
precisely, the slightly different colors manifest as these darker and lighter bands. And what's truly compelling here is that this observation conforms exactly to the methods of producing ancient linen documented by Pliny the Elder.
Pliny the Elder, the Roman author.
The very one, lived from 23 AD to 79 AD. He describes similar processes in his encyclopedic work, Natural History. This stands in stark contrast to medieval linen manufacturing.
How so?
Surviving high-quality medieval linens generally don't show this kind of banding because their production involved different, often more uniform, methods of preparing the flax. So this subtle banding, along with the unique herringbone weave, becomes yet another powerful piece of evidence suggesting the shroud's ancient origin. It helps separate it from a medieval context based on the very way the fabric was made.
Linen, it seems, has a remarkable memory, and the shroud's memory is apparently quite vivid. It preserves a fascinating record of its past handling and, well, its long history of display.
A physical memory in the fibers.
Yeah. When you examine photos taken with raking or grazing light, that technique where light shines across the surface at a low angle to highlight texture.
Shows up all the creases and bumps.
Exactly. Old fold marks become astonishingly clear in the linen cloth, which makes perfect sense, right? Linen has notoriously poor elasticity. That's why it wrinkles so easily and tends to permanently retain a memory of how it's been folded or creased.
We've all experienced wrinkled linen shirts.
Totally. But what's particularly intriguing about these fold marks on the shroud is their precision. Some are described by researchers as being as sharp as a straight edge. That doesn't sound like accidental creasing.
No, that suggests very deliberate, consistent folding over long periods.
Right. And there's also an interesting discoloration band specifically associated with one set of especially closely spaced folds. It suggests a very specific scenario, like these folds were consistently formed by the shroud being folded over the edge of something rigid, maybe a wooden block or a batten.
To keep it in a specific configuration, perhaps.
Yeah. This isn't random wear. It feels like a story of purposeful handling.
Yeah.
Maybe systematic storage or display.
And this immediately raises an important question. What kind of historical event or long-term use would necessitate such precise folding, perhaps even needing a specific device? And what does it imply about how the shroud was displayed or, venerated in its early history?
Did anyone look into that?
Yes, the research team at the Shroud of Turin Center, TSC, pursued this. They actually developed a computer program specifically to analytically map these prominent folds visible on the shroud.
A computer map of the folds.
Essentially, yes. And what they discovered was quite remarkable. The patterns of these folds were consistently aligned with the design of a hypothetical lifting device that could have been used specifically for raising and displaying the cloth.
A lifting device, like for showing it to people.
Exactly. Now, to be clear, we don't have the device itself, but the analytical consistency of the fold patterns perfectly matches the mechanics of what such a device would produce on the fabric over time. Imagine this large, precious textile, far too delicate and significant for casual handling, being regularly exhibited to crowds in ancient or medieval times.
You'd need a careful way to do it.
Absolutely. Such a device would have been invaluable for both presentation and preservation. It allows the artifact to be lifted and shown without excessive, potentially damaging human contact. This finding, etched into the fabric's memory, suggests not just casual storage, but a long history of careful, perhaps ceremonial presentation.
So the linen's memory points to early importance and formal veneration.
It certainly seems to, long before its documented history in Europe really begins.
Okay, so folds tell us about movement and display. But there's another structural element that raises more questions about its original construction. A seam. A seam running the entire length of the shroud.
A full-length seam, yes.
If you look closely, you'll notice this distinctive seam. It's positioned about 3 inches, or 7.6 centimeters, from one edge. This isn't just a minor repair. It looks like an integral part of the cloth's original or very early construction. Like this long, narrow strip of linen was intentionally attached to the main body.
It certainly appears that way.
It seems like a small detail, maybe a technicality. But its purpose has apparently been a subject of considerable debate among shroud researchers.
Oh, absolutely.
And as I understand it, the stitching used to create this seam holds some fascinating historical clues, too.
That's right. The seam itself is fascinating, and the theories about its purpose are deeply rooted in ancient customs and textile practices. One prominent theory, put forth by several researchers, suggests that this side strip was originally part of the main shroud, but was cut from it.
Cut off? Why?
Well, the hypothesis continues that this detached strip was then used for a specific purpose, perhaps, to wrap the dead body that was once enshrouded in the cloth, following certain ancient Jewish burial customs. Then later, after its initial use, it was meticulously re-sewn back onto the main body.
So used separately, then reattached. Interesting.
It connects the fabric itself to a specific, culturally significant burial custom from antiquity. But the real clincher, arguably, comes from the forensic analysis of the stitching.
The stitches themselves.
Yes. Mechthild Florey Lemberg, that leading textile expert we mentioned who oversaw the 2002 preservation, conducted an in-depth analysis of this seam. And she made a remarkable discovery. The stitching pattern used is strikingly similar, almost identical, to stitching found on a cloth unearthed in the ancient tombs of the Jewish fortress of Masada.
Masada, wow. When is that dated?
And here's the critical point. Masada cloth has been convincingly dated by archaeologists to between 40 BC and 73 AD.
Just century again, right?
Well,
the time frame.
Exactly. What's fascinating here is that the Masada comparison is particularly compelling. It provides a strong archaeological anchor for the seam's antiquity, and it offers a tangible link to ancient Jewish burial practices common in the Jerusalem region during that era. It's a remarkable forensic detail that strongly supports an ancient Near Eastern origin.
The shroud also bears marks of, well, more dramatic incidents, most notably what are commonly called the poker holes.
Ah, yes, the L-shaped holes.
Right. These aren't just random tiers. They're 4 matched repetitions of these distinctive L-shaped holes, clearly visible. And significantly, they definitely predate the big 1532 fire, which we'll get to.
That's a key point. They are older damage.
And what's unique about them is they show this progressive level of damage. One set, called level 1, has the most severe damage. Then level 2, 3, and 4 show progressively less damage. It's not random. It seems to tell a precise forensic story about how the shroud was folded when this happened.
A forensic puzzle, exactly. If we connect this to the bigger picture, this isn't just damage. It reveals the shroud's precise folding history and even hints at its ceremonial use in early religious contexts.
How so? How does the pattern reveal the folding?
Well, this distinctive progressive damage pattern has been meticulously analyzed. Forensic experts determined that at the time these holes were made, the shroud was folded exactly in 4 layers, first widthwise, then lengthwise.
Folded in 4, okay.
And the level 1 holes, the ones with the most damage, are located almost precisely at the very center of that folded bundle. This geometric progression indicates that whatever caused the damage was applied to the outermost layer.
And burned through progressively less material.
Exactly. Burning through less fabric with each successive layer, creating the graduated damage we see.
So what caused the damage? Was it a poker?
Interestingly, the favored hypothesis has evolved. Originally, yes, the thought was maybe a hot poker was thrust through the cloth. But the current, more widely accepted theory is that hot incense, or maybe embers, fell onto the cloth during its early pre-European history.
Incense or embers during a ceremony.
That's the idea. It likely happened while the shroud was being used in some kind of ecclesiastical rite or ceremony, perhaps during veneration. The pattern of burns is entirely consistent with falling embers, which would scorch the top layer most severely, and then less so through the layers below as the heat dissipated.
And is there any other evidence for that?
Well, this forensic finding also seems to link visually to historical illustrations like the famous Prey manuscript, that's a 12th century Hungarian codex. Some researchers interpret one of its illustrations as depicting these very holes, which would further suggest a long history of ceremonial handling and public veneration, far removed from its initial bimvio context.
And speaking of fire, there's the really well-known 1532 fire. This was catastrophic, but crucially, very well documented. It left undeniable marks.
Unmistakable damage, yes.
When you look at the cloth, you can clearly see these large areas of burn damage, distinct scorch lines, and numerous water stains, all unequivocally associated with that specific fire in 1532 in Chambéry, France, where the shroud was kept at the time.
A documented catastrophe.
And the geometrical pattern of the main burns is particularly telling. It offers a precise forensic insight. This wasn't just random. The worst damage happened when molten metal silver, actually from the lid of the shroud's storage casket, fell onto the linen inside.
Molten silver dripped onto it.
Yeah. Because the shroud was folded inside that casket, the molten metal created this symmetrical pattern of burns as it dripped through the layers. It's like a tragic snapshot of that specific moment in its documented European history.
What's fascinating here is that, unlike some other marks that require interpretation, the 1532 fire provides a definitive historical timestamp, an unassailable fixed point.
Because it's documented.
Exactly. The numerous water stains from dousing the fire are not only easily identified, but are incredibly well documented in historical records. This makes them an absolutely crucial fixed point in the shroud's timeline. Everything else can be compared against this known event.
And the folding was different then.
Yes, the distinct folding pattern associated with this burn damage is also highly significant. It's fundamentally different from the pattern we saw with the poker holes. Forensic analysis shows that for the 1532 fire, the shroud was folded into 8 distinct layers when the molten metal hit it.
8 layers, not 4.
Right. And knowing this precise configuration allows researchers to accurately differentiate older damage, like the poker holes, from this more recent event. It helps reconstruct the shroud's custodial history, showing exactly how it was stored at that time, and provides an invaluable fixed reference for analyzing all the other marks on the cloth.
But apparently, not all water stains are from that 1532 fire. Some seem to be much, much older, whispering an even deeper story.
That's right. There are other stains.
If you look meticulously, you'll notice many large water stains, not just from Chambéry, but also along the edges of the long dimension, and interestingly, along its central axis. For example, there's a prominent one right at the center of the abdomen on the frontal image.
Very noticeable.
And another significant one at the top of the head, right between the frontal and dorsal images.
Yes, near the gap.
The crucial point about these particular stains is their undeniable antiquity. They clearly originated from some event or situation that predated the 1532 fire.
So they are potentially ancient.
Exactly, hinting at a very different, much earlier period in the shroud's history. They aren't just recent damage, they're potential witnesses to its earliest storage, handling, maybe its initial travels, marks that predate its known European journey.
And if we connect this to the bigger picture, these ancient water stains and the compelling earthenware jar hypothesis really paint a vivid picture of the shroud's early preservation and handling. It suggests a sophisticated yet, still vulnerable form of storage long before it ever reached Europe.
Earthenware jar hypothesis. Tell me more.
This comes from the groundbreaking work of Aldo Guerreschi and Michele Cecito, published back in 2002. They meticulously demonstrated how the shroud's folding pattern, specifically associated with these large ancient water stains, is perfectly consistent with the shroud being carefully stored in an ancient type of earthenware jar at some point before 1532.
Stored in a jar, like the Dead Sea Scrolls.
Potentially a similar concept, yes. Their proposed mechanism suggests that water somehow leaked into this ancient vessel. Then, through the natural process of capillary action water wicking upwards, it soaked into a corner of the carefully folded shroud inside, creating these distinct stain patterns we see today.
That makes sense. Capillary action.
And what's even more fascinating is the potential connection to historical iconography, the Man of Sorrows icon, a very widespread and significant image in early Christian art.
Yes, I know the type.
It often appears to visually incorporate the specific water stain found at the center of the shroud's frontal image on the abdomen. This strongly suggests that these stains weren't just present, but were also recognized, perhaps even venerated, as an integral part of the image in ancient times. It further underscores the shroud's profound antiquity and its early veneration. 3. geographical footprints, environmental evidence.
Okay, now let's shift gears a bit. Let's talk about something incredibly granular, something we usually just, wipe off our shoes, actual dirt.
Dirt as evidence, yes.
You might think of dirt as just dirt. But on the Shroud, it surprisingly emerges as a powerful forensic witness, potentially carrying secrets about its geographical journey. So during that 1978 Stuart expedition, scientists meticulously collected sticky tape samples from the Shroud's surface, like using tape to lift off dust.
Standard forensic technique.
And these tapes captured microscopic particles. Subsequent studies established this as dirt, but not just any dirt. These detailed studies chemically showed that these particles were, quote, quite similar to the unique soil and stone characteristic of the area around Jerusalem.
Jerusalem soil.
Yeah. There's even this classic anecdote about the discovery. Roger and Marty Gilbert, part of the STURP team, were doing ultraviolet spectroscopy scans of the dorsal image area. When their equipment reached the soles of the feet, they got these unexpected chemical signals.
Something unusual.
Right. So they called over optical physicist Sam Pellicore. He looked at the area with his portable microscope and apparently exclaimed, "It's dirt!" And intriguingly, elevated levels of this same distinctive dirt were also found on the nose and the left knee areas.
Nose and knee. Points of contact with the ground, perhaps.
That's the implication. Consistent with falls, maybe.
And this specific discovery immediately highlights a crucial point about scientific rigor, how vital it is to design protocols from the outset to avoid later challenges to what could be incredibly compelling evidence. Let's really dig into the specific studies on this dirt evidence.
Okay.
First, the foundational work. The Kolbeck and Nitkowski studies from 1982. Ray Rogers, a STURP chemist, provided sticky tape samples to Dr. Joseph Kolbeck, a crystallography scientist. Kolbeck found calcium carbonate, basically limestone particles on tapes from the Shroud's foot area.
Limestone, common enough.
But the type of limestone can be a geographical signature. Kolbeck knew this and consulted Dr. Eugenia Nitkowski, an archaeologist specializing in Israel's unique rolling stone tombs. She provided him with limestone samples directly from Jerusalem tombs.
Comparing Shroud limestone to Jerusalem tomb limestone?
Exactly. Kolbeck's analysis revealed an incredibly close match. The Shroud limestone closely resembled the Jerusalem tomb limestone, both being the rare and very specific travertine or agonite variety.
Travertine or agonite, is that common?
No, that's the key. It's a unique crystalline form. Finding this specific type is like finding a very specific fingerprint pointing strongly towards the Jerusalem area, as it's only found there and a few other places globally.
Wow.
To double-check, Kolbeck took samples to Dr. Riccardo Levi-Setti at the University of Chicago. He used his high-resolution scanning ion microprobe and confirmed an unusually close match of wavelengths. They did add a scientific caveat, though.
Which was?
While it was a powerful pointer, they hadn't definitively proven the aragonite came specifically from a Jerusalem tomb, but the correlation was undeniable.
Still very suggestive. What other studies were done?
Well, later, the University of Padua did studies between 2009 and 2011. They analyzed dust collected from between the Shroud and its backing cloth by Giovanni Rigi Numana. Their project, Analysis of Microparticles Vacuumed from the Turin Shroud, found particles from Mount Zion in Jerusalem were indeed quite similar to the Shroud dust. Similar again. Yes, though their paper thoughtfully added a nuance. They stated the soil particles were typical of Jerusalem, but could also be found in other arid Mediterranean areas influenced by the winds of the Sahara Desert, so maintaining scientific caution.
Right.
And more recently, Gerard Lucat in Paris, in a 2015 study, examined a tape sample from the nose area using advanced SEM and X-ray microfluorescence. His results also pointed to a soil nature corresponding to desertic or semi-desertic climates.
So multiple studies pointing towards that kind of environment.
Exactly. The collective nature of this dirt evidence is compelling. Dirt on the dorsal foot area, consistent with a barefoot man. Dirt on the nose and left knee, consistent with falls. And intriguingly, separate tests on dirt from the Sudarium of Oviedo, another relic many believe is linked to the same individual, show chemical signatures correlating with the Calvary site in Jerusalem. That adds more weight.
But you mentioned issues with scientific rigor earlier.
Yes, and this is critical. The profound importance of this dirt research really only became fully apparent after the May 1978 Strap P project. So, the samples taken back then weren't part of a pre-planned protocol specifically designed for rigorous geographical correlation.
They weren't looking for dirt specifically with that goal in mind initially.
Pretty much. This led to somewhat limited sampling and, understandably, some criticism over the years regarding the precise chain of custody and management of some samples. Therefore, while incredibly suggestive, this dirt evidence is currently rated as Class 2 evidence by many researchers. Meaning it's significant, it's compelling, but its scientific strength can and, frankly, must be strengthened. A straightforward, crucial project for the future would be taking new, targeted samples with specific pre-planned testing protocols from strategic spots on the Shroud. That would ensure rigor from the start and provide unequivocal data, potentially elevating this to Class 1 evidence.
Okay, from dirt, we move to something even smaller, yet potentially even more powerful. Pollen. We're talking about the potential for a pollen fingerprint on the Shroud that could tell an astonishing story about its geographical journey through time and different climates.
What's fascinating here is the immense potential of paleontology. While Frey's work was pioneering, the significant advancements in the field since the 1970s mean there's a clear, exciting path to elevate this evidence and definitively trace the Shroud's ancient journey.
Paleontology, the study of pollen, right?
Exactly. Paleontology is the scientific study of pollen and spores. And in the 70s and 80s, a powerful sub-branch emerged, forensic paleontology. This focuses on analyzing pollen found on objects, crime scenes, archaeological finds, historical artifacts like the Shroud, using it as evidence to place that object in a specific location at a specific time of year.
How do pollen do that?
It rests on 4 remarkable scientific facts. First, pollen grains are tiny, 7 to 200 micrometers, mostly invisible to the naked eye. But despite their size, they have complex, unique shapes and structures. These often allow identification down to the species or genus level, though you often need a scanning electron microscope and SEM for the really fine details.
Okay, unique shapes. What else?
Second, they are incredibly resistant to decomposition. The outer wall, the exine, is made of sporopollenin. Think of it as nature's superplastic, one of the most chemically inert, durable biological polymers known. Pollen can survive for millions of years because of it, tiny time capsules.
Where?
Third, they're adhesive. Their surfaces have waxes and proteins held by intricate sculpture elements. This makes them stick firmly to almost any host surface, like linen, easy to transport and deposit.
Sticking time capsules. And fourth,
and this is key for forensics, each distinct geographical region has its own unique pollen spectrum, generated by the specific plants that grow there. Climate, soil, ecology all play a role. This unique spectrum acts as a relatively indestructible fingerprint of the region. Forensic paleontologists can use it to trace an object's movements through different environments.
a geographical fingerprint, got it. Who applied this to the Shroud first?
The pioneer was Max Frey, lived 1913 to 1983. He was a renowned criminal forensic scientist in Europe, founded the Zurich Central Police Scientific Department, and was a true pioneer in forensic paleontology. In 1973, after retiring, the Shroud custodians invited him to examine the artifact. On November 24, 1973, he took 12 sticky tape samples from the Shroud, specifically aiming to collect pollen. Now, Frey had a doctorate in botany, specializing in palynology, but his main career was forensic science administration, not continuous palynology practice. Still, he personally undertook the huge task of identifying the pollen.
A massive undertaking.
Absolutely. Over the next 5 years, he made 7 extensive trips: Palestine, Turkey, France, Italy, collecting over 300 regional pollen samples for comparison. In 1978, during the Stirrup expedition, he took 26 more tapes. Crucially, he never extracted pollen from those 78 tapes. He just used them visually with low-powered microscopes to cross-check his ongoing work on the 73 samples.
So what did he find in those 73 samples?
In June 1982, he published a preliminary article. He claimed to have identified pollen from an astonishing 56 distinct plant species, a real botanical journey, some from Palestine, some from Anatolia and Turkey, at least 4 from Constantinople, and some from France and Italy.
Wow, mapping a potential route.
Exactly. Frey's preliminary conclusion was profound. The pollen spectrum are a most valuable confirmation of the theory that the Shroud traveled from Palestine through Anatolia, Turkey, to Constantinople, France, and Italy. But then tragedy struck.
Oh.
He died suddenly in January 1983. He never completed his research, never fully subjected it to comprehensive peer review, or formally published his complete findings. A critical gap in verification.
It's terrible luck. Did anyone else follow up?
Yes, thankfully some supporting work has emerged. The University of Padua team, analyzing the vacuum dust, found pollen including Philaurea angustifolia. That's an evergreen, flowers March-May, adapted to Mediterranean drought, exactly the type Frey classified.
Okay, some confirmation there.
And Gerard Lucat's 2015 study on the nose tape using SEM identified pollen from the carob tree, Ceratonia siliqua, and the Judas tree, Balanites aegyptiaca, both common in Palestine, though not on Frey's preliminary list. Still geographically consistent.
So what's the current assessment? Still Class 2 evidence?
Yes, currently Class 2. Frey's preliminary results, supported by these later limited studies, do strongly suggest the fingerprint of the Jerusalem environs is on the shroud. But the reasons for Class 2 remain: his untimely death preventing full publication and peer review, and the lack of clarity on whether he consistently used SEM analysis for all his findings, which is crucial now.
But there's a path forward.
Definitely. Forensic palynology has advanced massively since the 70s. We now have detailed pollen atlases, online databases for all the relevant regions. Plus, those untouched 1978 Frey samples, now with Allen and Mary Wanger, are a palynological treasure chest, waiting for modern analysis.
Untouched samples.
Exactly. And even more importantly, the well-cataloged aspirated dust and dirt held by the custodians in Turin is an invaluable resource. Future work could coordinate with a new forensic palynology study of pollen on the Sudarium of Oviedo too. That could create a really powerful, interlinked body of evidence.
And if microscopic pollen isn't enough, some researchers claim to see actual images of flowers imprinted on the shroud.
Ah yes, the flower images. A more controversial area.
If true, that would be incredibly direct botanical evidence, right? But it sounds like there's debate.
There is, and this specific claim raises that important question again. Where's the line between observation and interpretation? How crucial is objectivity, especially when digital enhancement plays such a big role in seeing these images?
So how did this claim start?
It began when Paul Maloney, an archaeologist with Assist, borrowed 4 of Frey's 1978 slides. He noticed debris that looked like a flower anther. He consulted Dr. A. Orville Dahl, a palynologist, who confirmed it was an anther and even counted at least 11 pollen grains inside it.
Pollen inside an anther on the tape. Okay.
Later, Dahl looked up Frey's full list of 56 pollens. He noted a majority, 32, were entomophilous, meaning insect-carried, usually from flowering plants. The rest were mostly anemophilous, wind-carried, like from grasses or pines.
More flower pollen than wind pollen.
Right. That plus the anther led Dahl to propose a hypothesis. Maybe flowering plants were physically laid on the shroud at some point, leaving not just pollen, but maybe imprints.
Laid on the shroud? Like for burial?
That was the implication. Independently, Alan Wanger, also with Assist, reported seeing subtle image artifacts that looked like flowers in shroud photos he was studying.
Okay, so multiple people seeing things.
Then it gained wider attention in 1995. The Wangers showed enhanced shroud photos to Avinoam Danon, the world's foremost authority on the flora of Israel, especially around Jerusalem.
What do you think?
Danon's reaction was immediate and striking. He apparently looked for some 10 seconds and said that I saw images of a few plants I know from the Jerusalem area.
Wow. Just like that.
From then until his death in 2015, Danon studied shroud botany extensively. He eventually claimed to have identified images of 17 different plant species on the shroud.
17 specific species.
Yes, and his conclusions were remarkably specific. Quote, "The origin of the shroud is from an area between Jerusalem and Hebron. Only in that area could people bring fresh plants of these species from the field and put them onto a dead man's body. These plants indicated that the time of year was March through April. Very precise geography and timing."
That's incredibly specific. What's the current assessment? Do others see them?
Well, it's complex. Some Shroud of Turin Center staff members have reported seeing flower images, some matching Danon's list, even on unenhanced high-def shroud photos. So some visibility seems possible without enhancement.
What?
But it's crucial to clarify that many of the flowers Danon described are very difficult to make out with the naked eye. Perceiving most of them, and certainly identifying specific species, relies heavily on analyzing photos using computer software for manipulation and enhancement.
Image processing is key.
Very key. And even then, researchers themselves have noted that some coaching is generally required to see all of Danon's flower images. That highlights the challenge of objective verification.
Coaching implies subjectivity.
It does raise that concern, which brings us back to rigor. Respected researchers Murrah and Di Lazzaro put it well. Interpretations of shapes. Flowers or letters seen on Acropoieta images by means of image processing tools should be considered a track useful to address further studies, but they cannot be considered as self-consistent proofs.
Useful leads, but not proof in themselves.
Exactly. And the Shroud of Turin Center generally agrees. So while the flower image evidence is compelling in its implications pointing to Jerusalem in spring, it's currently rated Class 2. Strong, suggestive, but still circumstantial. It needs more objective, independent verification beyond enhanced visual perception before it's considered proven fact.
Finally, we get to an even more speculative category. Claims of seeing coins and other symbols on the shroud.
Yes, the coins over the eyes theory and other reported symbols.
Beyond flowers, some researchers claim to discern faint imprints of ancient coins, maybe Roman leptons and other symbols. What's the status of that?
What's fascinating here is that this category really highlights the extreme scientific caution required. This evidence-reported images of coins and symbols is currently rated as Class 3.
Class 3, so highly speculative.
Yes. At this stage, it lacks strong, independently verifiable supporting data or broad consensus. Like the more difficult flower images, visibility often relies on very high levels of image enhancement, making objective confirmation extremely challenging. So, not widely accepted yet.
Not scientifically established, no. While the possibility exists that future, even more advanced image processing might potentially strengthen this evidence, for now, the data just doesn't meet the bar for higher scientific confidence. It's a potent reminder that, in science, seeing, especially with enhancement, isn't always proving. Rigorous, objective validation is absolutely essential. Outro.
So what does this all mean for our deep dive into the shroud's linen? We've really gone on quite a journey, haven't we? From microscopic fibers, finer than hair, and that distinctive ancient herringbone weave.
Pointing to antiquity.
Right. All the way through the dramatic marks of history, the 1532 fire, those mysterious poker holes may be linked to ceremonies.
And the ancient water stains.
Yes. And then uncovering these subtle environmental fingerprints, the geological dirt matching Jerusalem, the complex pollen spectrum tracing a potential journey.
Even the debated flower images.
What consistently emerges from every angle, it seems, is a singular, powerful conclusion. The linen itself is this rich, silent, yet incredibly detailed historical document. Absolutely.
It provides a wealth of physical, chemical, environmental data that consistently points towards an ancient origin and a really complex multi-continental journey that clearly predates its documented European records. It's a fabric just steeped in history.
This exploration truly underscores how much history, how many layers of information can be intricately embedded in just a single artifact. It demands an interdisciplinary, meticulous, and frankly unyielding scientific approach to fully appreciate its silent yet incredibly detailed story.
Every thread, every mark.
Every crease, every burn mark, every microscopic particle contributes to this narrative spanning millennia and continents. It's really a testament to the power of careful forensic analysis, transforming what looks like an inert piece of cloth into a vibrant, compelling historical witness.
So as we consider this intricate tapestry of evidence, all woven into the very fabric of the shroud, what new questions does it provoke in your mind? Think about the journeys and transformations of historical artifacts, and how we interpret their silent yet incredibly detailed stories.